So this is the second video for 10.5 with the log functions. We're going to solve some equation with log. So you may see some of these questions on the exam. The first one, we have log base 5 9x minus 4 equal to 1. So like we say earlier, base of log, answer of log need to be greater than 0. We should always check our answer. And a lot of time if you're stuck with the log form, you can change it to exponential form. So remember the log form, we have log base answer equal to exponents. And the exponential form, we have base exponents equal to answer. I like to write many times until I feel comfortable with them, remember them. So let's see. This is my base. So when I rewrite that, I start with my base raised to exponents is 1 equal to the answer part 9x minus 4. So if you can rewrite them in the other form correctly, it really helps you to solve this. So we have 5 equal to 9x minus 4. Now we just need to solve for x, right? So basically I have 9 equal to 9x, so that's easy, divided by 9, x equal to 1, right? So, and if you plug it back in here, this should check. So that's the first one, change from log to exponential form. The second question they ask, 48, I just put some questions similar to your homework questions so you can have some example to look at. So if you have a equation like that, they say equal to -1, sorry. First, we need to use the property we learned, which is condense it to a single log. So when we condense it to a single log, this is subtraction, right? So subtraction will turn into division. Okay, so let's see. So we have log base 4 division. What go to the top? My first term x, the bottom part would be my x plus 3 equal to -1. Okay, so I condense it to a single log, applying the property. So now I'm stuck, right? So again, I'm going back to the stucking at log part. So I need to change my log to exponential. So this is a very important strategy you should use when solving this kind of problem. Okay, so let's see. I need to rearrange it. So my base is 4 raised to my exponents is -1 this time, equal to the answer part is x over x plus 3, right? Alright, so 4 raised to -1 is basically 1 over 4, right? Equal to x plus 3. So at this point, you can kind of multiply both sides with the LCD if you want to. You can also do cross multiply, right? So some people say, okay, the LCD is 4 times x plus 3, multiply both sides, it's the same as this. So this means 1 times x plus 3 equal to 4 times x. So I would have x plus 3 equal to 4x. And I can subtract x both sides. And this is 3 equal to 3x. Oh, that's kind of weird. Divided by 3, so x equal to 1 again. So again, if you plug it back in, it should check out. So this is 1 here is positive, that's good. This is 1 plus 3 is still positive, that's good. So number 48 is this. Okay, let's look at the next one. The next one is number 50. But we should always like plug it back in to see if it makes that a negative, okay? So double check that. The next one is number 50. So number 50 here, we got log x plus 5 plus log x plus 2 equal to 1. So again, first I need to write that as a single log. This is addition, will turn into multiplication, right? Okay, so 1 log, and then multiplication will turn into, addition will turn into multiplications. X plus 2 equal to 1. Okay, so once you have that, you can FOIL it, right? So x times x is x squared. X times 2 is plus 2x plus 5x, and then plus 10 equal to 1 here. Alright, combine like term, log x squared plus 7x plus 10 equal to 1. So I notice I don't have a base here, right? No base means what? Mean base 10. So I can also write this as log base 10 x squared plus 7x plus 10 equal to 1. And I'm stuck in this form, so what do I do? So after you put it as single log, I need to rewrite that from log to exponential. So it's very important you know how to switch them around, okay? So your base is 10 raised to the first power equal to x squared plus 7x plus 10. So basically 10 equal to this, right? So if that's the case, then this is quadratic. I should set this equal to 0 and maybe factor and solve it. Minus 10 both sides. Oh, this is easier than I thought. X squared plus 7x. I don't have a number here, so I don't really have to do AC method, right? So what do I do instead? We can still factor. What do they have in common? Both of them have x, so we can pull out an x times, this is x plus 7. So we set x equal to 0, x plus 7 equal to 0, subtract 7, so x equal to negative 7, right? And x equal to 0. Don't forget this is log, so we will have to check and make sure it's okay. So put a 0 here, this is a positive 5, that's fine. Put a 0 here, this is log 2, that's okay. So this is fine, but if I put a negative 7 here, negative 7 plus 5 will make a log base 10 of negative 2, so that's not okay. So I cannot have this because this is in the position of answer blocked. Need to be greater than 0. So on the test you will have to tell me why, and then you throw away an answer. So that's the only answer. So make sure base block and answer block are greater than 0. Okay, so that's number 50. The next one is number 60. So number 60 and 7, the next two, they say when you solve it, they want it to be 4 decimal places. So which probably suggests that we are going to need to use the calculator. So let's see. Let me need some more paper. Alright, let's look at this one, number 60. We are solving e raised to 2y equal to 15. So again, my problem is the unknown is in the exponent. And then I cannot make the both sides with the same base. I don't have the capability of making them the same base. So what I need to do is somehow bring down the exponents. So need to bring down the unknown exponents by one of the property we learned earlier. We can raise both sides with log or ln. So for this particular question, ln seems to be more useful because it comes with e, right? So and your book seems to suggest anytime if you need to raise something, you will raise to ln, so you don't have to really think about it. So I'm going to raise both sides with ln. And the reason we do that is we want the unknown exponents to come down using the power rule, okay? So we have e2y here, this is 15. So the 2y, because of the log, now can get down, right? So it's going to be 2y ln e equal to ln of 15. And ln e basically is what? 1, so this kind of go away. So you got 2y equal to ln 15. I'm solving for y, so the only thing I need to do now is divide both sides with 2. So now you can use the calculator, right? So, but be very careful when you plug that in, okay? So this say I have ln, like see my calculator start with the parenthesis, right? 15, so make sure you close that. Divided by 2. So I see a lot of times students forget to close the parenthesis immediately and then everything is wrong. So this one, they say 4 decimal places, right? So 1.3540 is my answer. Okay, so that's an estimation basically. So that's number 60. Next we're going to do number 62. Okay, number 62. We're going to solve 2 ways to x plus 1 equal to 6x minus 1. So this one have the similar issues basically. The unknown is in the exponent and I cannot get both sides with the same base, right? So if that's the case, then what you need to do is you need to bring down the unknown exponents, bring down unknown exponents by raising both sides with either log base 10 or ln. And your book seems to suggest just do ln each time, so you don't have to even think about it. So I'm going to raise both sides with ln. ln on the left, ln on the right. And then we have 2x plus 1 and 6x minus 1. Which, by the way, if you do ln or log, they should be exactly the same answer. So when we have log, we can apply the power property, bring down the exponents. So this would be parenthesis x plus 1, and then we have ln of 2, right? Equal to parenthesis of x minus 1, and then ln of 6. Okay, so sometimes students get to this point and they got really confused. What I want you to think about is ln of 2 is just a number, so you can pretend this is a 2. So if this is a 2, what would you do? You would distribute in here, right? So that's exactly what you need to do. So if you distribute this to this number and this number, treat that as like a 2, then you have x ln 2 plus 1 times ln 2, right? And then treat them as a 6, so you distribute this here again. So we will have x ln of 6 minus 1 ln of 6, right? So we are solving for x. So what you need to do is move all the terms with x to one side and all other stuff to the other side. Okay, so I have the x here and the x here. So, and then I have number and the number here. I kind of want to move my x term to the right hand side so I can start with a positive number. So let me write it one more time here so you don't get confused what I'm doing. Okay, so if I want all my x term on this side, then this guy stay, right? When this guy need to go, so minus x ln of 2 minus x ln of 2. So I'm just going to do one step at a time. So ln of 2 equal to x ln of 6 minus ln of 6 minus x ln of 2. And this guy doesn't have x, right? So this guy need to go to the other side by adding ln of 6, adding ln of 6. So eventually, all the stuff without x to one side, and everything have x together on one side. Are we okay? So we're solving for x. So both of these terms have x, right? So we can factor x out. So if we factor x out, then pull the x, and we have ln of 6 minus ln of 2. On the other side, we have ln of 2 plus ln of 6. So to solve for x, I just need to get rid of this part, right? And because this is multiplying to my x, so I need to divide both sides with ln of 6 minus ln of 2. ln of 6 minus ln of 2. So this is cancelled out. So this is the exact answer. And but we don't want the exact answer, we want 4 decimal places, right? So I need to plug that into my calculator, and you have to be very careful with this, okay? So let's look at this together. So I turn on my calculator, let's clear that, and on top I have ln of 2. You can put all of this together with the parenthesis, but I'm just going to do the top part first. Ln of 2, don't forget to close the parenthesis, plus ln of 6, again don't forget to close the parenthesis. I'm going to hit enter. This is my top part, right? And then I need to divide. I'm going to put a parenthesis all around the bottom parts. I'm going to have ln of 6, close that parenthesis, so make sure you start the parenthesis here first. Okay, sorry, here. Close it, and then minus my ln of 2, so again close that, and close that big parenthesis. So you put the bottom part in a big parenthesis, but close the ln parenthesis each time. So hit enter. My answer should be 4 decimal places, right? 2.2619 after I round it up. So that would be your answer, okay? We have one more, and then we will be done. Okay, so that was 62. The last question is kind of like a word problem. They say the U.S. Census has reported that the United States is becoming more diverse. In the exercise 51 of the previous section, the projected Hispanic population in millions was modeled by this exponential function. So we have this exponential function. T equal to 0 means year 2000, and then it's between year 2000 to 2050. The first one say estimate in what year the Hispanic population will double the 2005 population. So 2005 was 42.69 million. Use the algebra and log to solve this. So you are given, let me see, more paper. That may give you a little bit more room. Okay, let me try to do it here. So for number 89, we have h of t equal to 37.79 1.021 t. So this is the function they gave us. They want to double 2005 population, which is 42.699 million. So if you double that, you will multiply by 2, right? So 42.69 times 2 is 85.38 is the doubling number. So they want this to be your new h of t to solve for the time. So they found when, which is t equal to what, right? So I'm going to replace h of t with my 85.38 and then try to solve for t. so equal to 37.79, 1.021 t. So because I'm trying to solve for t, so I want to simplify the right hand side, right? So I'm going to divide both sides by 37.79. So depending on if it's a nice number, so 85.38 divided by 37.79 is not that great of a number, so it stops somewhere. So if you want to write out the whole thing, that's okay. The common practice is they're going to just leave it as a fraction. So 85.38 divided by 37.79. So this side divided by that is going to be gone, equal to 1.021 t. So again, t is my unknown, so I need to use the log property so I can bring down the unknown. So I'm going to raise both sides by, you can do log, but your book suggests to do ln. So ln on the left and ln on the right hand side. So ln on the left, ln on the right. So just write down that really big fraction here, that's okay. And then 1.021 t. So once we have the log property, we can bring down the exponents, right? So almost done. Just don't have a lot of paper left. Ln of these big fractions equal to t ln of 1.021. So all you need to do here is you're solving for t, so both sides need to be divided by whatever left here, ln 1.021, ln 1.021. So t is about, so let's put this in a calculator. So be extra careful. I'm going to start with ln, and then the top part would be 85.38 divided by 37.79. I need to close it, right? Hit enter. This is the top part of the fractions, need to be divided by the bottom part. We have ln, don't forget 1.021, and don't forget to close the parenthesis here, right? So this would be more than 39 years, so it's going to be 39.22 years. So remember we started at t equal to 0 is year 2000. So your book says just add this to it. So 2000 plus 39.22. So during year 2039, the population will double, right? Okay, so that would be the answer. So main part is like you will need to apply some of the log property, especially when you're solving something. So some of them we try to rewrite that from log to exponential. Some of them we need to do the single log, and other one we need to raise log and ln both sides in order to bring down the exponents. So please practice those properties and solving those problems, okay?